My dear students, welcome all to the NEET 2020 discussions. For any competitive examination, preparation of previous papers is very important. We are trying to solve last year NEET questions one by one. A detailed discussion we are taking here. The first question: a body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? See, this is the question from the chapter Gravitation. We know the weight means, suppose we are considering weight of a body is equal to mg, that you know, mg. Now that is given, that is equal to 72 Newton. They are asking what is the gravitational force on it at a height equal to half the radius. So when the height increases, the gravitation value or the acceleration due to gravity will change. So we don't know what is that value, so I am assuming that is x. So this gh value we studied, that is an equation for that. M into gh is gr square divided by r plus h, the whole square is the gh value. That is equal to x. Now h value we can substitute there. So mg r square divided by r plus h, r plus r by 2 the whole square is there. That is equal to, we can say mg r square divided by r plus r by 2, that is equal to 3r by 2. 3r by 2 the whole square equal to x. That we can say, that is mg r square divided by 9r square by 4 will come to the numerator, that is equal to x. See, this I can consider as equation 1 and this is 2. We have to find this x value. So we can take, that is equal to 2 by 1, which means here we can say mg is what now? 72. For that mg will cancel on both sides correctly. So we can say now, if you are taking the right side, x by 72 is equal to, look, this r square all square already cancelled. Mg also cancels. So 4 by 9 is there. Then x is equal to 4 into 72 by 9. So 72 by 9 is 8. So 4 into 8, 32 Newton. See, 32 Newton means the right option is 4. 4 is the right option. See, now we are going to the next question now. See, the second question is based on logic circuits. And see, if you are considering this one is now in the deleted portion, but for NEET examination this question came. Logic gates means it is a circuit in which there is a logical relation between input and output. The symbols of these gates are important to understand their operations. See, the gates I am saying, this is, see, a NOT gate. NOT gate means if the input is A, the output will be a complement. Now, another gate is there here in this diagram. This gate is an OR gate. OR gate. OR gate means it is addition. A and B. So here it will be A or B will be there. But see, here in the diagram, there is a bubble is also given here. So, look there, the bubble here stands for complement. So, this is now A or B complement. And then, we are checking what is the truth table there. As I said, look there, here A is there, so it should be A complement. This is A complement. This is B, therefore this will be B complement. And therefore Y will be there, that is A complement or B complement, all complement will be there. Just like this idea. For we can say now here, that is the output is now is equal to A complement or B complement, all complement is there. See now, we know that is negative of negative is positive. In that sense, we can say A complement of complement is A will be there. Or complement is and coming. Then B complement of complement is B coming. See now, the complement of or is equal to and. See, what is the and here? And means just multiplication, and gate. So, we can check the equivalent operation is A and B. So, we can check which option is right there. So, 0 and 0, 0 will be there. 0 and 1, 0 will be there. 1 and 0, 0 will be there. 1 and 1, 1 will be there. So, the option 3 is the right one that represents AND gate. Look once more, 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1 is there. So, we can say that is the right option here, it is option 3. Now, we are going to do the next question. See, here in question 3, in Young's double slit experiment, if the separation between coherent source is halved and the distance of the screen from the coherent source is doubled, then the fringe width becomes. So, options are there. YDS experiment is an important area in examination. And here in this YDS experiment, it is in the chapter Wave Optics plus 2, part 2, Wave Optics chapter, we have to study YDS experiment. So, here the YDS experiment, fringe width is there. Fringe width is same as band width. We know band width beta is equal to lambda capital D by small d is there. Now, they are saying separation between coherent sources is halved. So, this D is the separation between coherent source. So, for D is halved and the distance of the screen from the coherent source is doubled. So, the new bandwidth beta dash is equal to lambda. Look there, they said the distance between screen and the coherent source is doubled. Therefore, 4D divided by, and the separation between coherent sources is halved. So, D by 2 is there. It's doubled. Doubled means, see, we are saying that is equal to 2 here correctly. So, we can say this picture now correctly, that is here doubled, therefore see this is 2D and D by 2. Now we can write that is equal to lambda D by D. This 2 will come to the numerator into 4. So lambda D by D is beta. So we can say that is equal to 4 beta. Bandwidth increases by 4 times. Now we are going to do the next question. Look there, question 4. A capillary tube of radius r is immersed in water and water rises into a height h. The mass of the water in the capillary is 5 gram. Another capillary tube of radius 2r is immersed in water. The mass of water that will rise in this tube. See, this is the question in +1, part 2, mechanics of fluids, where actually the capillary rise is the topic here. So, what is the equation for capillary rise? H is equal to 2t cos theta divided by r rho g is the capillary rise. And see, for a given picture here, surface tension, angle of contact, density and acceleration due to gravity constant. So I can say H is proportional to 1 by R. H proportional to 1 by R. Here the topic is related to mass of water. How mass is related? So we know mass is equal to density into volume of the cylinder. See, what is the volume of the cylinder? Volume of the cylinder is pi r square h. So we can say that is rho into pi r square h is there. So if you are considering here the picture now correctly, look there, mass is equal to volume is there. Volume, what is the volume? Pi r square, h is the height. Okay. Therefore, if you are considering this h is 1 by r. H proportional to 1 by r already. We get that. For m is proportional to r square divided by r. So m proportional to r is there. For what we can say, mass is directly proportional to the radius of the capillary tube. So here, the radius, when the radius is r, they said the mass is 5 gram. Then when the radius is 2r, what's the mass? That's the question. You got the relation. It's directly proportional. So what we can say, this mass will be doubled. 5 gram becomes 10 gram now because the radius is doubled. So the answer is 10 gram. Right option is option 1. Okay, now we are going to explain the next question. See the question here. See, a cylinder contains hydrogen gas at a pressure of 249 kilopascal and temperature 27 degrees Celsius. What is its density is the question. See, here this question is based on the part 2 +1 textbook kinetic theory of gases, where the equations of ideal gas that PV is equal to nRT. So n is number of moles. How we can find the number of moles? Number of moles we can find mass divided by gram molecular mass. So we can write PV is equal to mass of hydrogen divided by gram molecular mass of hydrogen into RT. Now we want to introduce density there. So I am writing P. I am taking this capital M to the left side. Then M by V RT is there. So mass by volume is density. So we can say Pm is equal to rho RT is there. Then rho is equal to, we can say Pm divided by RT is there. Here one point is there. This mass, gram molecular mass, we know that is 2, but remember that is in gram only. For hydrogen, gram molecular mass is 2, but that is in gram. We want to convert that gram into kilogram. So 2 into 10 raised to minus 3 kilogram. And temperature is given in Celsius. The SI unit of temperature is Kelvin. So we want to convert that. 27 plus 273, that is equal to 300 Kelvin. Okay, we can substitute that here now. So rho is equal to P is there, pressure is given 249 kilopascal. So 249 kilo means 10 raised to 3. Then mass is 2 into 10 raised to minus 3 divided by R is there, R value given 8.3 and T is there 300. Here you know this 3 and minus 3 you can simplify and you will get the picture. That is, if you are doing this calculation, you will get the answer 0.2 kilogram per meter cube. The right answer is option D. Option D, the right answer. Now we are going to do the next question. See now, look to the question there. An iron rod of susceptibility 599 is subjected to a magnetizing field of 1200 ampere meter inverse 1. The permeability of the material of the rod is, see now, here they are asking permeability, susceptibility given. This question is in chapter 5 plus 2 magnetism and matter chapter related one. See now, we have the equation mu r is equal to 1 plus chi is there. Chi is susceptibility and mu r is relative permeability. So that is 1 plus 599 equal to 600. Mu r is 600. If you have mu r, we can find mu. What's the formula? Mu is equal to mu naught, mu r is there. You can recall the formula mu r is equal to mu by mu 0. Permeability of free space, permeability of the medium. Now mu naught value there given, that is 4 pi into 10 raised to minus 7 into 600, and then that is equal to 4 into 6 is 24. Okay, 24 pi into 10 raised to minus 5, and if you are simplifying here, you know, see 2.4 is there, therefore you can write that 2.4 pi into 10 raised to minus 4. Therefore, the right answer 2.4 pi into 10 raised to minus 4. Right answer is option 3 now currently. 3 the right answer. Now we are doing the next question. See, look, question 7. Find the torque about the origin when a force of 3 J cap Newton acts on a particle whose position vector is 2 K cap meter. How we can find the torque? So, no, it's a direct question. So, you know, torque we studied in the plus 1 chapter, part 1, rotational motion, system of particle chapter, we have a torque. So, you know, torque is equal to R cross F. R cross F, cross product here. Okay, so you know the position vector is given 2 K cap. So 2 K cap cross and force is given 3 J cap. See, you know, cross product rule is there. Cross product rule. There is an easy method to understand that. Already someone knows. I, J, K is there. Now, you know what's the idea here? What is I cross J? This is a sense. I cross j equal to k. K cross I is equal to j. Now j cross k is equal to I. Now if it is reverse, that is, if it is k cross j, because it is opposite of the sense now, that's why there is a minus I cap is coming. So 2 into 3, that is 6, and then here it is symbol k cross j. K cross j is minus I, so we can say minus I will be there. So the answer is minus 6 I cap Newton meter. Newton meter is the unit of, the unit of torque, Newton meter, or it is joule. So right option is option A. Option A, the right one. Remember cross product rule and take the equation torque is equal to R cross F is there. Now we are going to do the next question. See question 8. The average thermal energy for a monoatomic gas is, look, Boltzmann constant and T is the absolute temperature. See, if you are considering the average thermal energy, we have a equipartition theorem. We studied in +1, in part 2, the chapter thermal properties of matter. We have the idea, and then kinetic theory of gases. We studied detailed about this equipartition theorem. What is the equipartition theorem statement? The average translational kinetic energy of gas molecule is equal to F times half kBT. F times half kBT. What is this F? F is degrees of freedom. For monoatomic gas molecule, degrees of freedom is F. Here it is monoatomic given. So K, E, T is equal to, F is given, monoatomic, F is equal to 3. So we can say that is 3 by 2 kBT is there. Monoatomic gas molecule, degrees of freedom is 3. For a diatomic gas molecule, degrees of freedom is 5 coming. Okay, monoatomic gas, F equal to 3. So the right answer is 3 by 2 kBT. So option D. Now we are going to do the next question. See, that is question 9. Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has a diameter of 2 meter is. See, what is limit of resolution? Limit of resolution means the minimum distance between two closer objects to be just seen as separate is known as limit of resolution. Then suppose we are considering this limit of resolution in +2 in the chapter wave optics. We studied a limit of resolution of a telescope. The formula I am writing, limit of resolution of a telescope is equal to 1.22 lambda divided by D. Where what is D? D is the diameter of the objective and lambda is wavelength. So data are given here. Therefore we can say 1.22 into lambda is 600 nanometer. 600 into 10 raised to -9 divided by diameter is 2. Now you can simplify here 3 coming. So 1.22 into 3 into 10 raised to -7. This 0, 2 zeros are there. And that is equal to 3.66 into 10 raised to minus 7 radian. So the right answer is option C, 3.66 into 10 raised to minus 7 radian. So option C is the right answer. Now we are going to do the next question. See, question 10. Light with an average flux of 20 watt per centimeter square falls on a non-reflecting surface at normal incidence having surface area 20 centimeter square. The energy received by the surface during a time span of 1 minute is. See, question 10. This is the question in electromagnetic wave chapter. See, we studied energy flux. It is also known as intensity of light. What is intensity of light? So, we wrote that point. Intensity of light is equal to energy incident per unit area in unit time. For energy incident per unit area in unit time is intensity. So how we can find energy now? Energy is equal to intensity into area into time. Area into time. So what is the intensity given? 20 watt centimeter square. So 20 watt per centimeter square into what is area? 20 centimeter square. Now see, if you are considering here, this is in centimeter square and this is 20 centimeter square. What's the time given? Time is, see, if you are doing, that is equal to 1 minute. 1 minute. Okay. See, we can convert. Actually, this per centimeter square and this centimeter square cancels. So no need to convert this into meter square. Now we have a 20 into 20. Then 1 minute is there. That we have to convert into 60 seconds. For we can say 60. And simplifying this, 2 into 2, 4. 4 into 6, 24. 24 into 10 raised to 3 joule is the answer. So we can say option A, the right one, 24 into 10 raised to 3 joule. See, now we are doing the next problem. See the question here. The ratio of contributions made by the electric field and magnetic field components to the intensity of electromagnetic wave. So, electromagnetic wave means it has electric field and as well as magnetic field. So, the energy stored in electric field and the energy stored in magnetic field for an EM wave remains the same. So, we can say that is the ratio of the contribution of electric field and magnetic field to the intensity of electromagnetic wave remains the same. So we can say that is 1:1. The energy density of electric field and the energy density of magnetic field in a EM wave remains the same. So if electromagnetic wave has 100 joule energy, 50 joule is in electric field and 50 joule is in magnetic field. So the ratio will be 1:1. Now see here the question 12. Which of the following graph represents variation of resistivity with the temperature for copper? See, variation of resistivity with the temperature is an important topic in the NCERT textbook. In the chapter 3+2 current electricity, we have 3 graphs related to this. And see, this is a copper, see, copper is a metal. Copper is a metal. For metals, how the variation, metals, the variation is in this manner. This is the variation. And for alloys means see combination of metals. For alloys, the variation is coming like this. Now see rho T variation is in this manner coming. Now for see, and for semiconductors, this variation of resistivity with the temperature is coming inversely proportional like this. So here copper is a metal. So the right answer is option 1. As copper is a metal, this graph is valid, rho T graph. Now we are doing question 30 now. The quantities of heat required to rise the temperature of two solid copper spheres of radii R1 and R2. So now R1 is given 1.5 R2 through a 1 Kelvin R in the ratio. So we studied, it's a question based on thermal properties of matter plus 1 and see part 2. If you are considering the heat required to rise the temperature, we know we have the equation Q is equal to mc delta T is there. mc delta T. Now see both are copper spheres. So we can say C remains the same. And now delta T. So 1 Kelvin. So we can say change in temperature also same for both the spheres. Now what we can say? Q directly proportional to mass. So mass is directly proportional to mass is rho V. So V coming here, density is same. So Q proportional to rho V means rho sphere it is 4 by 3 pi R cube. So we can say Q1 by Q2 is equal to R1 by R2 all cube is there. And they give R1 is 1.5 R2. That is 1.5 R2 divided by R2 all cube is there. R2 and R2 cancels. See here 1.5 you can represent, that is as 3 by 2. 3 by 2. So we can say 3 by 2 all cube. 3 cube is 27 and 2 cube is 8. So the right answer is 27 by 8. 27 by 8. So option C, the right one, option C. Now we are doing the next problem now. The next one, 14th question we are doing. A resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, what's the length of 1 ohm resistance wire is? Meter bridge related questions are important for competitive examination. So the working principle of meter bridge is Wheatstone bridge, that you know. So here we can say, look there, there is a resistance R, and here we can say there is a resistance 10 ohm. This is 10 ohm. Now look there, this is a meter bridge wire. How the meter bridge wire is, if you are considering that that splits, see, look there, they said the meter bridge wire is divided into 3:2. So we can say if this much is 3, now we can say this is 2. In between here galvanometer is there. The bridge is balanced. Okay, for this much is 3 and this much is 2 coming. Now what is the meter bridge concept that P by Q equal to R by S? So I can say correctly, look there, R by 10 is equal to 3 by 2. P by Q equal to R by S. So R by 10 is equal to 3 by 2. So I can say R is equal to 30 divided by 2 equal to 15 ohm. So the unknown resistance here, it is 15 ohm. And what is the point here? Look, so if the length of the wire is 1.5 meter, then the length of 1 ohm resistance wire is. So now look there, what's the point here means? Look, if you are considering 15 ohm, look, 15 ohm has how much length? 1.5 meter. Then they are asking 1 ohm, how much is the length? That we don't know, I am taking at X, unknown value. So we can simplify this for what is coming. 15 by 1 is equal to 1.5 by X. X we can find, X is equal to 1.5 divided by 15. And the answer is 0.1. 0.1 means 1 into 10 raised to minus 1 meter. So right one is option D. Option D, the right one, 1 into 10 raised to minus 1. Now see, we are doing now question 15. The increase in width of the depletion region in a PN junction diode is due to. It is chapter 14 plus 2, part 2, solids and semiconductor devices. Direct theory question. See now, reverse bias. So, and forward bias are there. If you are considering reverse bias, okay, so now this is P and this is N. So now P region connected to minus and N region connected to plus is reverse bias. Okay, the region near the PN junction which contains no mobile charge carriers is known as depletion region. See, in P, holes are the majority charge carriers, and in N, electrons are the majority charge carriers. In reverse bias, holes are attracted by positive negative terminal because holes are assumed to be positive charge. Electrons are attracted to the positive terminal. As they are pulling away side by side, what happened to depletion region width? Depletion region width increases. So the width of depletion region in a PN junction is due to only reverse bias. Forward bias is opposite effect is there. Width of depletion region will decrease. So the right answer is option 4. It's reverse bias. Reverse bias. Now we are doing question 16. A 40 μ of capacitor is connected to a 200 volt 50 Hz AC supply. The RMS value of current in the circuit is nearly. This is actually plus 2 alternating current chapter part 1 question. See now here there is a 40 μ of capacitor is there. Therefore we can say capacitor connected to a 200 volt AC source. Okay, 40 μ of, and here voltage is given 200 volt and 50 Hertz. See how we can find the current here. So current I is equal to V by XC. XC is capacitive reactance. And see now, XC is equal to 1 by C omega. So 1 by C omega equal to VC omega is there. So now all datas are given. 200. Capacitance is 40 into 10 raised to minus 6. Omega is 2 pi F. So 2 pi into F is 50. Simplifying, we will get now correctly. So now here, if you are considering 2 into 50 is 100. Then here 100 10 raised to 4, now 10 raised to 5. Okay, then remaining is 8 pi, 5n minus 6, so minus 1. That is 8 into 3.14 into 10 raised to minus 1. So the answer will be 2.5 ampere. So right option 1 is the right one, option 1 the right answer. 16th. Now we are doing the next problem. So that is see 17th one. This question is see in our first year part 1 the chapter units and measurement. Taking into account of the significant figures, what is the value of 9.99 minus 0.0099 meter? See, we know when two values are added or subtracted, we have to keep the least number of decimal digits in the answer. So what is the 17th one? What's the question here? 9.99. And other one 0.0099. Look here, how many decimal digits? 2 decimal digits. Here how many decimal digits? 4 decimal digits. So therefore answer should have a minimum number of decimal digits. So answer will have 2 decimal digits only. For this 2 decimal digits, what is the answer now? 4. No need to solve this actually. You will get the right one. So right answer is option 4. Option 4. When we are adding or subtracting the numbers, in our answer we have to keep least number of decimal digits. Now option 4 is the right. Now we are doing the next problem. See, a charged particle having drift velocity of 7.5 into 10 raised to minus 4 meter second inverse 1. An electric field of 3 into 10 raised to minus 10 volt meter inverse 1. It has a mobility. See, what is the mobility equation? So, mobility mu is equal to the ratio of drift velocity divided by electric field. It is in plus 2 part 1 chapter 3 current electricity, where we have mobility. Mobility is the ratio of drift velocity to the electric field. Direct question. So drift velocity given 7.5 into 10 raised to minus 4 by 3 into 10 raised to minus 10. 7.5 by 3, 2.5 into 10 raised to minus 4 and 10. So it's coming 6 now. So right answer is 2.5 into 10 raised to 6. Option D the right one. Option D the right one. 18th. Now we are doing the next problem. So that is question 19th. So in a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the original frequency of B will be. First of all, beats frequency means F frequency of 1 minus frequency of 2. F1 minus F2. So here the original frequency of A is given. Frequency of A is given, that is 530 Hertz. And the beat is given 6 Hertz. So the possible FBR, FB, frequency of B are two values possible. Because we don't know what is value of FB. Maybe it is FB minus FA or FA minus FB. So 6 is the difference, means 536 possible and 524 possible. How 536? 530 plus 6. And how 524? 530 minus 6. These two possibilities are there. Now what they are doing? Tension in the B is slightly decreased. You know, tension formula, we studied the equation for frequency. Frequency is equal to 1 by 2L root T by mu is there. This is the frequency in a stretched string. Qatar is, if you are considering, is a stretched string correctly. Now if you are considering here, tension reduced means frequency also decreases. Frequency decreases. Now what we can say, in the case of, now when the tension is reduced, the possible FB values are, look, original A is 530, difference is given 7. So what are the values coming? 530 plus 7, 537. Next one, 530 minus 7, 523. Now look these values now, 536, then you will get 537. If it is 524, you will get 523. What's our conclusion? When tension decreases, F also have to decrease. So if I take 536, there is a problem, I am getting 537. So this is not the right, increasing only. If I took 524, then I am getting 523. So tension is decreasing means here frequency is decreasing. So this possibility is the right one. So we can say option 4, the right answer, option 4. It's a 524 hertz. Now we are doing the next question, and this is the last question today discussion. Look, so now two particles of mass 5 kilogram and 10 kilogram respectively are attached to the two ends of a rigid rod of length 1 meter with a negligible mass. We have to find the center of mass of the system from the 5 kilogram particle is nearly at a distance of. So you know, this question is from the chapter rotational motion and system of particles, and so you know, this is in part 1 plus 1. Okay, now center of mass. So you know, here two masses are given. The masses are 5 kilogram and 10 kilogram separated by a distance 1 meter, separated by a distance 1 meter. See, in order to find the center of mass, what's our method? We are keeping one mass at the origin. So we are keeping this 5 kilogram at the origin. Okay, for you know, see, this is our x-axis. This is the origin. Now see how we can locate the center of mass now. So now here the coordinates of 5 kilogram, x equal to 0, y equal to 0. 10 kilogram, x equal to 1 because it is at 1 meter distance, and we can say y is equal to 0. What's the x coordinate of center of mass? X is equal to m1 x1 plus m2 x2 divided by m1 plus m2 is there. So the x coordinate, look, first part is 0. Therefore 10 into 1, 10 into 1 by, we can say m1 plus m2, 5 plus 10 is there. So that is equal to 10 divided by 15. Okay, 10 by 15 means we can say 2 by 3, 2 by 3, 0.66 meter or 666 continuation. For we can say that is equal to 67 centimeter. If you round off 6666, for we can say that you round off into that is 2 decimal digits, 0.67 is coming. 0.67 meter, and that is equal to 67 centimeter. It's a time to wind up. We'll meet again with high energy and I wish you all a day and a week and a month for a hard preparation. Thank you.